So this is the pass and the merit for experiment 3, which is your hemocytometer experiment. And you've set up the hemocytometers in class, and you've done the measurements with the yeast, and you've written up a sheet like this, inoculation of liquid medium with microorganisms, with the technique, the method, and so on. And you've also done the sterile technique. So you've done that already. So the pass is actually just collecting some results, and the merit is processing these results. Counting. I'll do one of the counts just to remind anybody who wasn't there in class what we did. So you have a sheet like this with results, and you have lots of different sugars. Yours are in black and white, but I've got a nice colour one here for different sugars. This one's maltose. So I'm going to write the sugar name there, maltose, and this is day 0, and then we've got day 1 there. So we're going to do all the counts, and those are going to go into our two boxes there. So for day 0, we're going to count these, and we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 20, 22, 23, I missed one, there we are. So 24. So counting those, and I've done the other counts already, so that'll be 24. I've done 19, 25 and 25 there, and I've also counted these already as well. So I've counted 28, 29, 32 and 37 across here. So I've done all those counts. We can get rid of those. We're calculating a mean. So to calculate the means here, I'm going to add these up and divide them by 4. So if I give you this, these are all the equations I'm going to use. Mean, count them all up, divided by 4. So here, I'm going to go 24 plus 19 plus 25 plus 25 is 93, divided by 4 is 23.25. I'm just going to round that off to 23. Down here, 28 plus 29 plus 32 plus 37 is 126, divided by 4 is 31.5. I'm going to round that to 32. So that's my calculating the means. Number of cells per microliter, we need to times that by 10 because of the dimensions. It was 1 times 1 times 0.1 millimeters. So we need to times that by 10, and then times that by another 1,000. So our 23 times by 10, you do these in your head, so 230, and then times that by another 1,000 is 230,000. This one will be 32 times by 10, 320, and then times it by another 1,000 to get it per mil, 320,000. And those are the numbers that I'm going to put in this table here. So for maltose, day 0 is 230,000, and day 1 is 320,000. We can work out percentage change. Here's the equation for percentage change. So our percentage change is cells day 1 minus day 0 over day 0 times by 100. And our numbers are sales on day 1, which is 320,000, minus day 0, which is 230,000, divided by day 0, which is 230,000, times by 100. 320,000 minus 230,000 is 90,000, divided by 230,000 times by 100. Is 39%. So I'm going to put those into my 39%. Don't need the units in the table because it's already in the header, and that is an increase. And I've already done the other counts, so I can put those in here. For sucrose, 210,000, 260,000, 200,000, and that was galactose. And lactose, 220,000, 420, 300, 250, 250,000, and 110,000. So if you haven't got any results, you can use these. When I've done my calculations for percentage change, I've got 100, I've got 15, 39, 25, and 50. These were increases. And my lactose was actually decreased because that went, and that was minus 50. So that was a decrease. So my conclusions for this is, which gave the best increase. So best increase is sucrose, because that was a 100% increase. Then maltose, galactose, and glucose. Then if we just say that lactose gave a decrease of 50%. And also what we can work out is a growth rate. So I think you just need a growth rate for each one as well. So you can just work these out using this equation here. So similar start to the equation, but we're just dividing it by 24 to give the number of new cells produced per hour. So if I put that there, so let's give you an example calculation here. Let's do it for our maltose again. So this is growth rate is the cells on day 1 minus the cells on day 0 divided by 24. So same numbers, 320,000, which is there, minus day 0, which is 230,000, divided by 24. So that's going to be 90,000 divided by 24, and then I need my 90,000 divided by 24 is 3750, and that is cells per hour. So you can do that for each sugar. I'm not going to do them all for you. This was maltose. So you've just put those on a separate sheet. And that's you're working out percentage changes and growth rates. We've identified the best sugar for growth based on that data. And that's really all you need for the merit.